Okay, today we start talking about linear functions and their graphs. So what we need to remember is that my airliner doesn't always work. A function whose graph is a line is called a linear function. Now, today I'm splitting up this section into two parts as I have been doing. So today we're going to talk about graphing an equation of the form ax plus by equals c. And that is in standard form, so it's called the standard form of the equation of a line. A, b, and c are numbers, and a and b cannot both be zero, but they can be easily graphed by using intercepts. Now, the intercepts that we're talking about, first off, we have the x-intercept. And the x-intercept is the point where the graph crosses the x-axis. Therefore, it's going to be a point coordinate x comma 0. We also have the y-intercept, and that is the point where the graph crosses the y-axis. And therefore, it will be 0 comma y. But I want to emphasize that it's a point, but these points are what we're going to use to actually graph our line. So to locate the x-intercept, you set y equal to 0 and solve for x. To locate the y-intercept, you're going to set x equal to 0 and solve for y. So it doesn't matter which one you do first, but one of the things that makes it easier is if you will think about if you want to find an intercept, when you put 0 in for x, you get to ignore that. So I have an equation that says 3y equals 6. Divide both sides by 3, and you find out that y is equal to 2. This is when I set x equal to 0. When I set x equal to 0, that goes away. I have 3y equals 6, divide by 3, y equals 2. That gives me the point y is 2, x is 0. Now, all I have to do is take this piece and cross out the y one, the y part. So if I say, let's go set y equal to 0, and when I set y equal to 0 in my problem, it goes away. I'm left with 2x equals 6. Divide both sides by 2, and I'll get x equals 3, which then gives me the point 3 comma 0. So 3, 0, I go over 3, up 0, there's that point. 0, 2 says I go 0 left and right and go up 2 units. And now there is the equation that I have 2 points, and if I connect those points, let's go connect them with my line. Make sure, some people not doing this, that you can put arrows on your equations as you graph them, because they do continue forever and ever. And then I'm going to do my best to connect those 2 points. Okay, I get to adjust mine to make sure that I've got them. Okay, so there's my equation of the line. So each time you do that, and you can move that out of the way, but you're covering up one of them, you have an equation, you solve it. You cover up the other one, you have an equation, you solve it. So that's what you're going to do in practice. You plot those 2 points and then you connect them. Okay? The last thing that I want to talk about is what you have talked about before, and this is called the steepness. The steepness of a line is what mathematicians call the slope of a line. How steep is the mountain? Then I'm thinking about what's the slope of that mountain. Okay, it compares the vertical change to the horizontal change and can be expressed in many different ways. So what we have here that you want to remember is that slope, okay, as I just said, is the vertical change, okay, this is a symbol in math and science for change, over the horizontal change, or y'all might know it also as vertical change is the same thing as the rise, horizontal change is the run. Sometimes we say that's the change in y over the change in x. But you should all be familiar with this formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And more importantly, you need to remember that it's denoted with the letter m. Okay? So when you calculate these, what I want to see you do to help you remember is connect the two y values on top and connect the two x values on bottom. Oh, my thing just decided to shut off on me. There we go. Bring that back. Come on. Okay. Connect the x's on the bottom. So my slope, okay, I connected the y's on top because I'm going to say 4 minus negative 2. I connected my x's on bottom. You have to start with the same point. Negative 3 minus negative 4. So 4 minus negative 2 is 6. Negative 3 minus a negative 4 is a positive 1, which means that my slope is 6. Okay? And one thing what I want to point out again, as I said, you got to make sure that you start with the same point. Doesn't matter which point, but these two numbers have to be in the same point as that right there. That means that you're starting with the same point. Okay? So again, if you'll connect your y's, draw a line connecting your y's on top and your x's on the bottom, that will help you keep things straight. So m is negative 2 minus 5, subtracting, and then 4 minus negative 1. Remember, we always like to put parentheses around those negative numbers to help keep our signs straight. So that's negative 7 on top and 5 on the bottom. And that's my slope. So the last thing, just to show you, is I gave you examples of the possibility that you will have of slopes when you do this, when you do your calculating. Okay? So keep in mind that if your slope is greater than 0, that means your slope is positive. Okay? And that means that your line will rise. So when you do your classwork, your written work, you have to also tell me whether your line will rise or fall. So because I have a positive slope, my line rises. You're always looking at it from left to right. So you're starting on the left and you go up, which is a positive slope, so we rise. Okay? If my slope is less than 0, that is a negative number. Again, looking at it from left to right, it falls. So again, when I graph this eventually, then we know that it will be falling. Okay? And these last two, okay, just so that you remember, if my slope is equal to 0, then I have a horizontal line. And when you do your calculations, 0 is what you get when you have 0 divided by a number. That is equal to 0. Okay? It's undefined if it's a number on top of 0, and that is undefined. And the other way to try to help you remember that is think of yourself walking. Okay? Can you walk along this surface? Yes, you can. Can you walk along this surface? Not very easily. So this one is impossible, undefined. That's a vertical line. This is easy to walk on, so it has a slope of 0. So hopefully that was a review from what you've had before, and let me know if you have any questions.